Hello, everyone, and welcome to our first set of notes for the school year. Today, we will be covering the classification and properties of numbers, specifically on the complex number system. Just to give you a background, all the numbers that you've been learning for the past year in your math classes are being categorized in a specific set of numbers. And some of you are very familiar with how you call it, but today we're going to understand how they are all related in a complete complex number system. So if you notice in this diagram, everything that you will be learning under the complex number system involves the complex number, the imaginary numbers, the real numbers involving the irrational and all the rational numbers, the integers, the natural, and the whole numbers. So some of you are very familiar with it, but let's go back and define again. So we have some important vocabularies today that we want to define, and we want to have some examples, just so we could understand how we write them and how we categorize these kinds of numbers. Okay? So in math specifically, it's important that we know how to write these set theory numbers mathematically. So I'm also giving you the ways on how to write it. So in natural numbers, it's usually denoted as letter N, capital N. And these are the numbers that you've learned when you were younger. So it's the counting numbers that you know, right? So what are those counting numbers? You're very familiar with that. Everything starts with a 1, 2, 3, and so on, right? So all of those are natural numbers. And the whole numbers, denoted by the capital W, are all counting numbers. But what is something that we add here as whole numbers? That includes 0. Okay, so everything in the natural number plus 0, right? So 0, 1, 2, and so on. Okay? Okay. Now for integers, it's denoted by the capital letter Z. And for integers, we say that these are all the positive whole numbers and the negative whole numbers. Actually, there's no term for that, but if you have a negative and they are categorized like a whole number, then these are all the integers that you have. And again, it includes 0. So this includes the 0, the positive negative 1, positive negative 2, and so on. Okay? Now, when we talk about rational numbers, it's denoted by this capital letter Q. And rational numbers are defined as real numbers that can be written as a ratio of two integers. Okay, so if you think about that, when we say a ratio, it's a number over a number. So we're basically thinking of a fraction here. Okay, some examples would be like maybe 2/3, a negative 1/2. 4 could be also a rational number just because you could represent this as over 1. And always remember that rational numbers include also the numbers that are repeating or terminating numbers. So for example, we have 6.2, that's a rational number, or some number decimals that are repeating like 0.44 with that bar on top. So all of these kinds of numbers gives you a rational number. So if you ask yourselves that, can a rational number be an integer? Yes. Can a rational number be a whole number? Definitely. So if you look back in the diagram, see, that's why rational numbers are within the circle. It's in It's in the bigger circle, and everything that contains it are these smaller circles. So all rational numbers can be integers, counting numbers, whole numbers, and stuff like that. All right, so let's go to irrational. Everything that I said for rational, this would be denoted as that with a bar on top. An irrational would be any real number, real numbers, that cannot be written in the form of a ratio of two integers. So what are these? These are like specific numbers that you're kind of familiar with, but has like non-repeating and non-terminating decimals. So this includes radicals that are not perfect squares. So when I say perfect square, I can't give like square root of 4, because if you still simplify that, that would still be a whole number or an integer, right? So for it to be irrational, it should not be a perfect square. So root of 2, root of 7, some are like numbers like e, Euler's number, like that. You will learn about this later on, and you're very familiar, I think, with pi, right? That gives you non-repeating and non-terminating numbers, decimals. Okay? So for the real numbers, this would be denoted by capital R. So for it to be real, it could either be rational or it could be an irrational number. But except an I, which is an imaginary. Okay, so everything that you've learned here previously, here, could be a real number. Okay? And all the examples that you have could be all of the ones above. Now, when we say imaginary and complex numbers, I think some of you are not yet familiar with this. It's important that we understand that these two follow a form A plus BI. This is something that represents a complex number already. Okay? See that? So when a complex number is given, a complex number is represented by a form A plus BI, where A is the real part and BI is the imaginary part. Okay? So when can something just be an imaginary number? Well, an imaginary number would look like this. An I is equal to square root of -1. So anything that has a negative radical, radicand, that makes an imaginary number. So an example of this would be 3i, a square root of -2, -4i. So this follows the same form, which is a plus bi, but we have to remember that if it's only an imaginary number, the a is 0 in value, because a and b are a possible set of real numbers in that form. But if a is 0 in this form, what happens here? A will be cancelled and you are left only with that imaginary number. So in short, for us to say that you have an imaginary number, it's a complex number where a is 0, right? And on the other hand, if we have a complex number, we have a plus bi form, but we know that the a and b are real numbers here. So what could be an example of that? It could be, let's say, a could be a whole, like 2 plus 3i. So in this example, the 2 here is the a, which is the real part, and the 3i here is the imaginary part. And once you have both a real and an imaginary, a combination of that, and you follow the form a plus bi, that's the only time that you have a complex number. Right? Another example here would be like a -2 minus 3i, 4 minus I. So a combination of a real and an imaginary will be a complex. So a complex can contain an imaginary number. So these two are like always connected with each other. Okay, let's have some examples. So for the ones I'm going to show you here, I just want to answer all the odd numbers. So we will be answering only the odd numbers, and the rest you will practice the even numbers. And later on, I'll be giving a complete answer key for this one. I want you to practice on your own first. So you could also check on yourself if you really understood the concepts we have or we shared in this lesson. Okay, so let's just have a very quick review on what are the notations that we use, so that we'll just write short the letters. So we have the natural number, the whole number, we have the integers, the rational, the irrational. We also have the real. We have the imaginary. Sorry, integers, this is E. And we have the complex, which would be, all right, so let's start. Let's start with number 1. So we have your -10. So -10, it could be an integer, right? It could be an integer. And since it's an integer, it should be rational and it should be real. Okay, try number 2 by yourself, and let's do number 3. So number 3 is a mixed number, and you can simplify that, right? So we have 9 times 1 is 9 plus 7, that gives you 16. Then we copy the denominator. And if you take a look at this fraction, what have you noticed with the fraction? Is that the simplest form? Right, so if that would be the simplest form, this is a ratio of 2 numbers that are integers, then this would be a rational number, and since it's rational, it is also real. Good. Now try number 4. Let's do number 5. Now if you look at number 5, that's 2.48. It's a decimal, right? But what kind of decimal do we have here? So it's it's repeating or terminating numbers, right? So if you have something like that, this will be a rational number, and since it's rational, it's also real. Okay, good. Now for number 7, notice that pi minus pi can still be simplified, and that gives you 0. And 0 is a very special number because it is included in a lot of types of set of numbers, right? This could be defined under the whole number system, right? It could be in the integers. It could also be in rational. And since it's irrational, it should be real. Okay? And now notice that we have 0.15 and there's a bar on top of that. What does that mean? That's repeating, right? So if we have decimals that are repeating, these are considered to be rational numbers. And since it's rational, it's also under the set of real numbers. Okay? -8/3 here gives you a ratio. So even if there is a negative over there, we know that it represents a ratio of 2 integers, right? Because negative could be given to like -8 or -3. Since that happens to be a ratio of 2 integers, then we say that this is rational. And since it's rational, it should also be under the set of real numbers. Okay? So for the rest of the even numbers, I want you to practice and define like what are the different types of set of numbers that will be specifically for all of these types of numbers. Okay? Now let's do numbers 1 and 3 here. We're very familiar that pi is a specific number that falls under an irrational number. And since it's an irrational, it could also be a real number, right? Number 3 is very similar to what we have. I'll leave that. I want to answer number 4 here. Notice that this follows the form a plus bi, and a and b are both real numbers, so we could say that this is a complex number, right? Okay, so when we look back at the discussion that we had here, it's important that for you to reflect on how these complex number system were arranged and how it evolves later on. Okay, because everything that you've learned so far are mostly on the real number system, but later on we will be introduced how to solve, like for example, an imaginary number or complex numbers. Okay, but it's important that in this lesson you know how to identify what type of set it is under the set of the complex number system. So again, in this notes, I would like you to practice everything that you could answer for all the rest of the even numbers. And I want you to reflect on the following questions. So I want you to reflect on which part of the real number system or the complex number system are you very familiar with? You mean you're very confident in solving, simplifying, stuff like that? You could write it on there. And what are some numbers that you need to be very familiarized with? You think that you need more practice or you need more orientation in how to solve it, right? This will be very helpful for you to discern on or reflect on what kinds of numbers you should be very aware of, just to make sure that as we go on the year, you know that, oh, these are the parts that I need to improve on or I have to work on, right? So again, this is the first lesson that we have for the set of complex number system. It's a review of all the types of numbers in the set theory concept, and I hope you get familiarized with this. Again, thank you for watching, and please answer the rest of the exercises.